Okay, this is hanging equilibrium with two separate angles. So this would be like your situation where you could have a sign hanging, you're not going to know both tensions, or you could have a person hanging from a rope or something like that. But in the end, your free body diagram will always look the same. You're going to end up having one tension coming off this way, you're going to have another tension going off that way, and you'll have some sort of a weight or something going straight down. Except the difference from this to the easy kind of questions is we'll have two different angles. So in this case, we're going to take 10 degrees and we're going to take 15 degrees. We're going to indicate this as tension 1. We're going to call that as tension 2. And this will be our weight, which will give us a number. We'll call it 7,000 newtons. Okay, so that's going to be our free body diagram that we're going to use. First thing you need to do before we figure out tension 1 and tension 2 is break it into our components. So blue, blue, and then we're going to have pink, pink, and pink. What that means is that we're going to have x's and y's. Our blue has to equal blue, so our x is going to equal our x, and our pinks have to equal, so this pink plus that pink has to equal this pink. That's what we're going to do. Before we do that, let's just simplify all the components. This is going to be T1x, T2x, T1y, T2y. Okay, now we have it all. We can do our sums. Sum of fx, sum of fy. So let's do that. My sum of fx statement, basically what we need to say here is that blue equals blue. So T1x is going to have to equal T2x. And then we're going to break that down even further. We know T1x is going to be T1 cosine of 10. And T2x is going to be T2 cosine of 15. Okay, so that's what we've got. T1 cos 10, T2 cos 15. And I'm going to just solve this thing for T1. That's going to end up being equal to T2 cosine 15 over cosine of 10. I would take this, figure it out in your calculator so that you have a statement in terms of numbers. So T1 is going to be equal to T2 0.981. There. So 98% of T1. Or sorry, T1 is going to be 98% of T2. Okay, so this is going to be like our equation that we're going to hold on to use a little later on. Our sum of Fy ends up being the same thing. We're going to work all out to get a T1 and a T2 in the same equation, and then we'll do two equations to unknowns. So what we'll do is go T1y plus T2y. These two have to equal 7,000. T1y is going to be T1 sine 10 degrees. T2 is going to be T2 sine 15 degrees. Make sure that you use 10 degrees and 15. I always go 10 here and I put 10 there just because you're so used to thinking in terms of only one angle. That has to equal 7,000. Now what we're going to do is we're going to take this T1 and we're going to put it into here. Okay, so this is going to come there. So I can go T2 0.981 sine of 10 degrees plus T2 sine of 15 degrees equals 7,000. Okay, so that's what I've got. I'm going to simplify the 0.981 times sine of 10, and then I'm going to simplify the sine of 15. So when I multiply this all out, I actually can make another statement simplifying it out. This will end up being 0.170 plus sine of 15, so that'll be T2, 0.259 equals 7,000. You don't have to do all these signs. You can leave them all together and do them all at the end. I like doing them at first so that I have definite numbers to work with. T2 plus T2, I'm going to take that and I'm going to end up going 0.7 plus 2.59, which will end up giving me 0.429, and that's equal to 7,000. So in the end, your T2 is going to be 7,000 divided by 0.429, which will leave you with, well, here, I'll write it for you. 7,000.429. T2 ends up equaling 16,000 317 newtons. That's T2 for right here. 16317 newtons. Okay, that's T2. Now I want to find T1. If I know what T2 is, I'm just going to plug it in to my T1 equation here. So I'm going to get T1 is going to be equal to 16317.981. So my T1 ends up equaling 16,000. Oops, one too many zeros there. 16,007 newtons. I'll write that again. 16,007 newtons right there. That's T1. There you go. Wait a second. Forgot to write this down. 16,007 newtons. There, I just wrote it there. So there's my two tensions.